Okay, so I know a lot of you probably still are struggling with this whole time value of money concept and how it applies to long-term liability. So I'm going to take you through this problem fairly slowly in hopes that you can understand it and go back and watch it as many times as you can. So uh, remember from class and in prior courses that when we look at bonds in particularly, bonds are nothing more than a contract, and it's a contract between two parties. Okay, on one side of the contract we have investors that have money, and on the other side of the contract we have the debtor that's going to borrow the money. In the example here, the Stanley Tile Company is the borrower and the bond holders are the investors. So they need money, the debtor, and the investors have the money, and so they're going to come to some terms in this very formal agreement, and the details of the agreement will determine how much the investors are willing to give the debtor for the specified contract. And we're making the assumption here, and this is the case with all bonds, that the investors are not stupid. So, in other words, they are going to only give the debtor the present value of all the future cash flows listed in the contract, because otherwise they could take their money somewhere else and invest it in an alternative and earned a comparable return. So they're not stupid. So here we go. So we have three different types of bonds that are actually being issued to the bond holders, and let's just tear this apart one at a time. The very first group of bonds say that it will pay 10% annual interest. Okay, so now what's important here is that we understand that this interest rate right here refers to what we call the stated rate or the coupon rate. And the 10% listed here is what's known as the market rate or the discount rate. And the relationship of those two interest rates is very, very, very important. It tells us whether we have a bond that sells at the face value, whether it sells at a discount or a premium, and it sets the stage for the entire amortization and how it's accounted for. Okay, so for the first group of bonds, the contract says, okay, I'll pay you interest, I being the debtor, I'll pay you, investor, interest on July 1st and January 1st for the next 5 years. 10%, I'll pay you 10%. 10% of what? 10% of the face value of the bonds, 10% of 1 million. So in other words, if you did that math, I'd pay you $100,000 every year, because this is stated at an annual rate, give you $100,000 every year, or $50,000 every 6 months until the bond matures. And then when the bond matures, you get the entire $1 million back as well. Okay, so that gives us enough information if we're the investor to say, okay, what is this bond really worth to us? And it's worth nothing more than the present value of all the future cash flows, but there's two types of cash flows in this bond. One type of cash flow says, I'll give you the $1 million, the face value back at the end of the bond when it matures, which is 5 years from now, or 10 interest payment period, because we're going to get paid interest every 6 months. So I need to know, what is it worth today if in 5 years, 10 interest payment periods, it's worth $1 million. So the present value of this portion of the contract equals the future value, 1 million, times some factor that we're going to pull off of a table, a present value table. It's a present value of one payment. So the present value of one payment, I've pulled this over here, I'll just kind of lay it right here. Present value of one payment, a one-time payment, 10, our n is 10, so to figure out what factor we pull off the table, we need to know the interest rate, which is listed on the x-axis, and the number of interest payments. Okay, so the interest payments is vertical on the y-axis. So how many payments are there? There are 10 payments because it's a 5-year bond, and we make interest payments every six months, twice a year, times 5 years is 10 payments. So I go down to 10 payments, and the interest rate, if you look, what interest rate do we use is an often misunderstood concept for students. They often don't know which rate to use. In this first group of bonds, it's easy. They're both the same, 10 and 10. We will always, always, always use the market rate of interest, the discount rate, when we're trying to figure out the present value. So it's this one right here, the 10%. So we are going to go over 5%, and down 10 interest payment periods. So 0.61391 is the factor we pull off of the table. So if I look at this formula, I'm just going to type 0.61391. That's my factor, and the future value is 1 million. So the present value of this portion of the contract is no longer a question mark. It's the factor. Let me just change that. The factor times the future values. So they'll give us $613,910 today if we give them $1 million 5 years from now. But we've guaranteed them more than that in this contract. We guaranteed them interest payments every 6 months. Interest payments in the amount of 10% of the face value. 10% annually is $100,000, but we're going to make that payment every 6 months on July 1st and January 1st. So we cut that interest in half, and that's why I used 5% as well when I went and looked at the tables, because the interest payment periods are every 6 months. So this is an annual rate. We cut that in half. So I'm going to make a $50,000 payment every 6 months. It's going to happen over and over and over and over until the bond matures, and the amount's going to stay the same. So my payment amount is $50,000. My interest is 5% because it's 10% annually divided by 2 because it's a semi-annual payment. So the value of that portion of the contract, it's an annuity. What's the present value of that payment every 6 months for 5 years is going to be, the formula is the size of the annuity, which we just figured out, times some factor we're going to pull off of a table. It's going to be a different table. It's not this table. We're going to go look for the present value of an ordinary annuity, because the annuity happens at the end of the payment period, not at the beginning. That'd be an annuity due. And so I have 10 payments total, 5 years times 2 payments a year. And my interest rate, the market rate is 10%, cut in half is 5%. I go down 7.7217. 7.7217 is the factor. We said the annuity is 50,000, so the present value of this portion of the contract is the 50,000 times the 7.7217. So in other words, the investor, which is very smart, is going to give us $386,085 for this portion of the contract. But a bond has 2 pieces of the contract. This one big payment, and they'll give us this amount for that one big payment, and all these $50,000 payments made along the way, and those are worth this. So that contract is worth a combination of both of those portions. And what you'll notice here is this is very, very, very close to $1 million, and we would actually round up here. And that, I didn't even have to do this math up front to figure that out, because I could have looked at the relationship of the interest rates. The market rate, which is here, matches the stated rate on the bond, and they equal, so the bond sells at what we call par value. So the investor here is willing to give the debtor $1 million for Group 1. So the total proceeds are $1 million. We round it up. I forgot to add a 0. $1 million. Present value of the interest payments was this, and the present value of the lump sum was this. Okay, so we're going to go through that same calculation for the 2 other groups. Now these are unique because what you'll notice is that the interest rates are different. The interest rate stated on the face of the second group of the bonds is higher than what was on the first rate. So that means we're not going to give them $100,000 a year. We give them $120,000 a year. You cut that in half, the interest payment moves to $60,000. So we go through the same calculation again, but my interest rates, do they stay the same or are they changed, right? So that's the question, and most of you, I was the same way when I went through this course and tried to understand time value of money. I couldn't figure out which interest rate to use. Always use the market rate when you're figuring out the present value, and the market rate is still 10%. You cut that in half because we're making semi-annual interest payments, and you have 5%. So we are still going to use 5%, but and so this 613,910 isn't going to change for any of the groups of the bonds, because they are all going to have the same amount repaid at maturity, and it's subject uh, to the same interest rate. Now, what does change though is the size of the annuity, because they're willing to pay us more here. So 112% times 1 point million is 160,000. Remember, that's an annual rate, so actually my annuity size becomes 60,000. So hold on, these values are changing. 386, 085. So the present value of the interest payments for the second group of bonds is 463,302, and I went through the same logic that we had in the first groupings of the bonds. So my group 2 present value interest payments is 463,302. So now, just take a second and notice what happened here. The second group of investors that bought these bonds is willing to give the debtor more than the $1 million they're seeking on the face value of the bond. And I could have looked at this problem right here, and I could have told you that up front that was going to happen, because whenever the market rate here, 10%, is lower than the stated rate, the investors are saying, holy cow, that's a really good deal. 12% interest on something that we think has a risk of only an equivalent risk in the market of 10%, will flock to this sort of investment, and we'll even pay you more, which in essence drives that rate down to an effective rate of 10%. So anyway, so they're going to pay us more. We have a premium on this bond. And for the group 3 bonds, the only thing that changes is, notice what happened to the interest rate. It dropped from, it's below even the 10%, so it's down below 8 to 8%. And remember what that does is this percent, the stated rate, is the only reason we use these percentages here is to figure out the size of the annuity, the size of the interest payments we're going to guarantee to pay back to the investor every 6 months. So you take the $1 million, the face value, times the 8% would be 80,000. You cut that in half. That means my annuity drops to 40,000. And so what happens is the present value of the interest payments for the third group is 308,868. You add those two together, and you'll notice that the investors aren't willing to give the debtor $1 million for this face value bond that has $1 million. And again, the reason for that, I could have told us that this bond would be sold at what we have here is a discount, because the investors are saying, no, I don't think so. This bond has you're much more risky than 8%. This isn't enough return for the risk we're asked to take on. So we're going to force you to pay us 10%. And the only way we can force you to pay us 10% is to offer you less. We'll make up for the difference in the interest rate right here. Okay, so now all of that to tell you that these three figures here dictate how much cash changes hands from the investor to the debtor on day one when the contract is signed, sealed, and delivered. So by deleting that, let me just type this in here quick. Okay, so now the first part of the problem, which we can now easily answer once we've calculated the present value of each group of bonds, is saying, okay, what's happening on January 1st of 2016? These two parties are shaking hands, investors giving money to the debtor, and I'll do the entries separately. I'll say on January 1st of 2016, and remember, we're the debtor here. We're the one, the corporation, and so we're going to get cash. Our cash is going to increase by these total proceeds. Remember, I rounded up there. And in exchange, we're going to enter into a long-term contract, a long-term liability, a bond payable, $1 million. So this is to record the issuance of the Group 1 bonds. Okay, so that's what you would do there. Very straightforward. The second group of bonds, however, is a little less straightforward because we are getting more cash. Remember, we're the debtor. We're going to get cash in the amount of $1,077,212. Remember, that's what a rational investor is going to give the debtor based on the stated details in the contract. But in exchange, the debtor said, look, I'm only going to repay you the $1 million at maturity. So what we're going to do is we're going to record this bond payable, and we always record the bond payable here as $1 million because that's the face value of the bond. But we have a difference here, right? We're not going to promise to repay $1,077,212. That's not stated in the contract. And so what happens here is we create this account called bond premium. what we call a valuation account. And so it's going to be for the difference because debits have to equal credits. $212. So debits equal credits. We'll talk about what we do with that and what it means in the latter parts of the problem. So this is to record the issuance of Group 2 bonds. And then the last one on January 1st of 2016 is for the Group 3 bonds. We're going to get cash of $922,778 because that's what the investors have agreed to give us. We're going to put a bond payable. I'm going to skip a line actually. We're going to put the bond payable here. Remember, we're only going to repay $1 million because that's the face amount on the bonds, and we have what's called a discount. We had to sell the bonds at less than face value. We had to put them on sale, in other words, by $77,222. And so this is to record the issuance of the Group 3 Group 3 bonds. Okay, that should conclude this very first requirement here and give you an understanding of how and why it is that we have a bond that sells at what we call par value, face value, a bond selling at a premium or issuing at a premium, and a bond that's issued at a discount, and how we initially record them.